Hello everyone and welcome to today's lecture for the ARD series of LYT Mode, in which we will be studying the chapter 4, that is Agrometeorology, and this basically is again a part of the Nabard grade A as well as the phase 1 as well as phase 2 syllabus, and grade A and the grade B as well. So over here, agrometeorology, as the name suggests, is the amalgamation of agriculture with meteorology, or the study of climate. Okay, so without wasting any time, let's begin with the chapter. And in the very first slide, we will try to understand the syllabus that is going to be covered over here. So it's a very brief syllabus, not much given in the details of Nabard syllabus as of yet, and not many questions actually let's say expected out of this topic in the exam, but maybe one or two can definitely come, have been seen in the previous years as well. So the main things would be the agroclimatic zones, the meteorology, the weather parameters, and the crop weather advisory. Okay, so that's what's defined in the syllabus, though it's written in only 4 terminologies, but they actually expect us to cover the entire chapter of agrometeorology over here. Okay, so let's begin then. The introduction would be the basic details of meteorology and agroclimatic zones. I mean, you must be thinking that what is this agroclimatic zones, this terminology that we're talking about. So let's begin with that first of all. Agrometeorology. So let's first understand meteorology. Meteorology is basically defined as the study of the Earth's atmosphere. Okay, study of Earth's atmosphere. And meteorology basically studies weather and not climate, right? So what is weather and what is climate now? So weather and climate are again two very differential terms used interchangeably in general everyday common language, but they actually have two different meanings and they are two separate terms altogether. So weather is basically the whatever is happening in your let's say atmosphere. Is it raining? Is it hot? Is it cold? In the short term, what is happening today, what is happening tomorrow, it can vary, right? That is called weather. But at the same time, we know that May, June, July are summer months. August, September are July and August basically are supposed to be July, August, even September are supposed to be monsoon months in India. So rainy season is expected. Then again, December, January are expected to be winter months in again the subcontinent of India, or let's say the northern hemisphere again. And what happens is that these basically generalize things, or how the long term pattern of atmosphere has been seen, and how it's been seen and recorded in the long term, let's say in the last 50 to 100 years. That tells us the long term average of what's going to happen. That is known as climate. Okay, so climate is basically long term. But if we talk about short term, so it's raining today, it's hot tomorrow, maybe it's windy day after tomorrow. That short term, which changes every day, every hour as well, and weekly basis it keeps changing, so you can keep seeing it at different parameters, daily, hourly, weekly, monthly, whatever. So that becomes weather. All right, so these are two separate terminologies, and they need to be understood well before we can enter this topic of meteorology and agrometeorology. So climate is basically the average of conditions which are expected at a certain place over a number of years, and it's a long term phenomenon. And at the same time, weather is the state of atmosphere on a current day and at a current time. All right, so again I will mention short over here, which can make things easier for you. Short term. All right, so let's move on to the next definition now, which is agrometeorology. So now that we've understood that meteorology is basically the study of Earth's atmosphere, and it actually studies weather, which is basically short term events happening in the atmosphere. So now, what is agrometeorology? Agrometeorology is basically the amalgamation of two words, agriculture and meteorology. Now we've understood the meaning of agriculture in the previous chapters, but then what is agricultural meteorology? It is basically the branch of meteorology which investigates the relationship of animals and plants to their physical environment. So let's say if it's hot, then the transpiration in plants would start increasing, right? And at the same time, if it is cold, then only plants like coniferous trees will be able to survive. and if it is let's say the autumn season, the plants will actually shed their leaves. So whatever happens in meteorology directly or indirectly starts impacting the living beings in the surroundings, right? Be that animals or be that plants. So the relationship or the interconnection between this meteorology and the plants and animals is basically known as agrometeorology. All right. So that's the basic definition. And now let's move on to agroclimatic zones. So the next definition, which is again most important, this term is directly given in the syllabus of Nabard. This is basically agroclimatic zones. So what are agroclimatic zones? Agroclimatic zones are basically, it's a term which is defined by FAO as a land unit represented accurately or precisely in terms of major climate and growing period. So basically, if you define let's say this is an area of land, maybe let's say two states, right? So maybe you define them into four different groups. Let's say this is a colder zone, this is a drier zone, this is a extremely wet zone, and this is a intermingling of all of these kinds of conditions. So this area would have a different climatic zone, and at the same time a different kind of vegetation. This area would have different, this area would have different, this area would have different. So these separate areas are basically agroclimatic zones, because these land units are basically represented in the form of their major climatic and growing periods, major climatic conditions and growing periods. All right. So this is basically a rough definition of agroclimatic zones. If you want to go into a more precise definition, which you might be able to use, let's say in the upcoming descriptive exams, which Nabard is now moving towards, you can say that it is the classification of regions based on climatic, physical, and socio-economic suitability. Climatic, physical, and socio-economic suitability for a certain type of crop. Okay, so that is what agroclimatic zones are. Now FAO has actually defined the entire, divided the entire world into 17 agroclimatic zones or ACZs. And these 17 climatic zones, agroclimatic zones, are basically subdivided into 73 subzones. All right. But in India, the Planning Commission of India has divided the Indian subcontinent into only 15 ACZs or 15 agroclimatic zones. Why only 15? Because out of these 17, there are two zones which are not found in India, and they do not concern us, at least for the exam. Okay. So what concerns us is the 15 zones which are found in India, and this map actually shows the details of these 15 agroclimatic zones. All right. Each of them is given in a separate color, in a separate zone, in a separate color. You can easily try and understand what kind of a let's say region are we talking about, and you can at least go through this maps again, not easy to ask in the exam, but you should know roughly which area lies where. Okay, so moving ahead, agroclimatic zones in India. So there are basically these 15 agroclimatic zones, and which states are exactly being covered, that you could see in the map. This table gives you a more detailed overview of that, so you can understand which states are being covered over here. You can actually go through this table, study it, understand it well, and maybe prepare these basic states, though chances are less for this to be asked, but you should still know this. And again, this has been given by the Planning Commission. Okay, so this entire let's say the division of India into 15 agroclimatic zones has been done by the Planning Commission of India. All right, moving ahead. So LGP, now you guys must have come through the terminology LPG in everyday general usage life. But what is LGP? LGP is basically a very important terminology in agriculture, which is also known as the length of growing period. Okay, so it basically refers to the number of days which are available for a crop or multiple crops to grow in a year in any ecosystem. Okay, so there are various types of ecosystems, like arid ecosystem, semi-arid, basically drier ecosystems. Arid is, let's say, the Thar Desert can be considered to be as an arid ecosystem. Then there are island ecosystems, coastal ecosystems, basically coastal areas where there is a lot of humidity, a lot of rainfall as well. Island ecosystems like the Andaman and Nicobar Islands, the Lakshadweep Islands. So there are basically different types of ecosystems, and for every ecosystem, the number of days that are available for plants to grow would be different. For example, in the Thar Desert, there are very few days which are actually ideal for the crops to grow, less than 90 days in a year. Similarly, in island and coastal ecosystem, there's a lot of humidity. The conditions are also neither too hot nor too cold. Very, very ideal for plants to grow. Again, more than 210 days are available for a plant to grow in a year. Same goes for the humid per humid ecosystems in Bengal and Assam. Okay, so LGP is basically the length of growing period or the number of days available for a plant to grow in a year in that ecosystem. So this table gives you the 3 and 3 6 different types of ecosystems available, 6 different types of ecosystems and the length of growing periods available for the plants every year. Okay, so I mean it's not difficult to remember these 6 at least length of growing periods, and I definitely believe that you should be remembering them. So not difficult to remember at all. Arid 90 days, semi-arid 90 to 150, subhumid 150 to 180, can go up to 210 days, and the last 3 ones very easy, 210 plus days, or basically more than 9 months. Sorry, more than 7 months. Yeah. So that is the ideal, growth, the length of the growing period which is available for the plants in these regions. Okay, guys. So let's move to the next slide then. Let's try and understand what the atmosphere is now. So atmosphere is basically made up of 78% oxygen, 78% nitrogen, 21% oxygen and 1% other gases. Okay, so this is the basic composition of atmosphere which any child would know. And again, these layers of the atmosphere, again, you have studied in your basic classes, in your schools, in your colleges and everywhere. But again, I'll just give you a brief description of it so that we can move towards understanding of in detail of the further topics. So again, troposphere is the lowest layer. It is the most dense layer. The average height is 12 kilometers, but it actually ranges between 8 to 18 kilometers. Okay, 8 to 18 kilometers. Then again, the next layer is stratosphere, which also contains the ozone layer, and this ranges up to 50 kilometers. Then there's the mesosphere, 80 kilometers. Then there's the thermosphere. Thermosphere also contains ions, or the ionosphere. And space shuttle is shown flying over here. So ideally, the flights or the aircrafts fly right above the troposphere and in the stratosphere. That's the ideal place for them to fly, because most of the weather phenomena, they are actually contained in the troposphere. So again, that is an important fact for us. And then comes the exosphere. The exosphere ranges up to space, but ideally 1,000 kilometers or so is what you can say, and 400 kilometers is where the thermosphere goes. So that's the basics of your atmosphere. Then the area classification. Okay, so now areas are basically classified into 4 different types, that is arid, semi-arid, sub-arid and humid. These terms you also came across when you were studying the length of growing period, but I'll define these terms for you now. So these are basically the classification of areas based on the amount of rainfall or the precipitation in those areas. Okay, so there are 4 basic classifications. The first is arid. Arid is basically the driest one, which is less than 500 mm of rainfall. Then comes the semi-arid. So this is in between arid and sub-arid, and this basically contains 500 to 750 mm of rainfall. Then comes the sub-arid. This is again a very decent amount of rainfall, between 750 to 1000 mm. And humid is the wettest, which contains more than 1000 mm of rainfall in 1 year. Okay, so all of these are per annum or per year. So this is the basic definition, and you have to remember this. I mean, this is a very basic question which has been asked, and it can be asked this year as well. All right. So moving ahead, factors for classification of climate. Now there are 3 basic factors which are used to classify climate, which has these classifications have later been done with formulas used by Köppen, Thorne, White, Troll, and even ICAR. So what are these 3 factors? The first is evapotranspiration. What is evapotranspiration or ET? This is basically it refers to 2 process is combined, which is evaporation and transpiration. All right. So what happens is that whenever water is there on the earth's surface or anywhere, and let's say the sun is shining and it's getting hot, then evaporation takes place, wherein the water can start getting converted into vapors and moves into the atmosphere, a very basic process which everyone knows about. So whatever water is present in the soil, on the surface, and even on the plants, it actually evaporates as well. And then there is the process of transpiration, wherein the leaves of the plants, their lower surfaces, they transpire water, right? Again, a very basic kind of a process which takes place. This is a cooling mechanism as well as an interchange of an exchange of gases which takes place from the lower surface of the leaf, and your vapors of water are transpired. Okay. So if anyone does not know about transpiration, it's a very basic process. You can go to Google and understand it. But for now, evapotranspiration is basically a combination of evaporation plus transpiration, and that is the very first factor for classification of climate. Then there is the second factor, which is PET, or the potential evapotranspiration. So what is PET? PET is the maximum amount of water that would be evapotranspired if infinite water were available. Okay, so whatever happens is, let's say there is an entire pond or an entire lake full of water which is available on the surface. Now what would happen is, if the sun rises, a lot of water would evaporate, right? Similarly, if there is a tree which has a lot of water which is going to its roots, in that case, and let's say the temperature is high, in that case a lot of water would get transpired from its leaves. But what if this lake shrinks to a very small area, and very less amount of water is available now? In that case, if the water is not available in sufficient quantity, then the evaporation would also get reduced. Similarly, if the tree is not getting enough amount of water through its roots, then it won't be able to transpire that amount of water which it ideally can. So potential evapotranspiration basically counts, or let's say measures, the amount of evapotranspiration which can occur if infinite amount of water is available, or basically water is not a limiting quantity for the evapotranspiration process. All right. So that is PET. Then comes precipitation. Precipitation is again a very, very simple thing. It's basically any type of water that forms in the Earth's atmosphere and then drops onto the Earth's surface. For example, rain, hail, sleet, snow, all of those are forms of precipitation. Very basic. So these are basically used by people like Köppen, Thornthwaite, Troll, and even the ICAR to create classifications of climate. And these classifications have been given by very simple formulas, and then they've been divided into, let's say, 3 to 4 categories on the basis of the results gotten through those formulas. So these formulas and the details of these classifications are very, very theoretical, very, very basic. They've been given in our notes. You can go through the notes, you'll understand them easily. It's very simple. All right, so I won't actually waste your time in trying to explain you something which is a very theoretical and practical, very theoretical and number based, and it doesn't even need to be explained. So I'll just move forward to the next concept, which is isopleth. So what is an isopleth? Isopleth is basically a line on a map that connects places with similar meteorological conditions. Okay, similar meteorological features. For example, an isobar is an isopleth. So everyone must have heard about isobars. Isobars are basically lines on a map which connect places having same pressure. Bar means pressure. Similarly, isotherm, therm means temperature. So this is a line on a map which connects all the places having the same temperature. Similarly comes isoheight, which connects all the places with the same amount of rainfall. Okay, so basically isopleth is any line on a map which connects the places which have similar meteorological conditions. Okay, so next is the weather forecasting types. Now again, because we know about weather, the next important thing that is very crucial to agriculture is forecasting of weather. Why? Because if we can forecast that, let's say it's going to rain a lot in the next few days, or maybe it's going to be a drier season this time around, or maybe it's going to be too hot, too cold, then at least the farmers can accordingly prepare themselves for those conditions, and in that case the crops can be saved in advance, right? So weather forecasting is a very crucial concept for agriculture, and there are multiple types of forecastings that can be done. So the first type of forecasting is a short range forecast, which is for less than 72 hours, so less than 3 days basically. Again, the short range can further be classified into nowcasting and very short range. Nowcasting is basically 0 to 2 hours, and very short range is 0 to 12 hours, and then again short range up to 72 hours. Okay, then is the second one, which is medium range. Medium range comes from 3 to 10 days, and anywhere above 10 days going up to 1 month or maybe even one season is known as a long range forecast. Okay, so there are multiple organizations that provide forecasts like IMD, World Met Department, and many other organizations. Basics have been given again in the notes, and you can go through them. But these are the ideal types of weather forecasts. Then comes the crop weather calendar. So I know that you might not be able to read what is written in this calendar, what is written in this image, but this image wasn't put over here for you to read it. This was just put over here to give you an overview of how a crop weather calendar looks. So the crop weather calendar basically has three components: the lower part, the middle part, and the top part, right? So the lower part basically consists of the phenological stages of the crop. So the sowing, the germination, vegetative growth, flowering, grain formation, harvesting. So it basically, the lower part gives us the uh, phenological conditions, phenological states of the plant, right? Then comes the middle part of this crop weather calendar. This middle part contains the ideal weather conditions or the favorable conditions. Ideal weather, right? So what is required for each of these stages to happen? What kind of temperature, rainfall, any other climatic condition, maybe let's say your height above sea level, all of these things, altitude basically, all of these things can be covered. And then comes the topmost portion, which contains the warnings, or let's say the anomalies, right? So what weather anomalies can occur, what do you have to do in those cases, all of these things are basically covered in the weather warnings or the top section. Okay, so these are the three basic components of a crop weather calendar. Again, go through the notes, you'll be able to understand the crop weather calendar. It's a very basic thing, and it's very easy. So I just wanted you to actually have a look and visualize how a crop weather calendar looks like. Okay, so next is the IMD seasonal rainfall. So IMD is basically classified rainfall into 6 types. So you must have heard these basic terminologies, like the IMD is said that the rainfall will be normal this year, it will be deficit this year, there will be an excess of rainfall this year. So all of these are basically definitions given by the IMD. So what IMD has done first of all is, it has created, let's say, a point which is given as the average rainfall for the last few years. Okay, it's been taken over a course of 50 years, and an average rainfall for the Indian subcontinent has been taken. Now what happens is that beyond this average, the IMD has defined a few points. Let's say these are plus minus 20%. So 20%, this is plus and this is minus, or basically a deficit of rainfall, and this is a surplus of rainfall. So these are the points of 20%. Then comes 60%. Okay, so over here is negative 60%, and then comes beyond that. So if the rainfall lies within this first range of minus 19 to plus 19 degrees Celsius, basically lesser than these 20s, then it is known as a normal rainfall. Okay, the next one is, if it lies between 20% positive to positive 59%, just below the 60, 20% to 59%, then it becomes excess rainfall. Similarly, if it lies between negative 59% to negative 20%, it becomes deficit. So these are excess and deficit rainfalls. Then If this goes beyond this 60%, 60% or higher, then it becomes large excess, and if it goes beyond minus 60% or even lower, then it becomes large deficit. And then there is one more: if there is 0% rain or basically no rainfall, then it is practically defined as no rain. Okay, so these are the types of rainfall which the IMD has defined for India. All right, so moving ahead, cloud seeding. So what is cloud seeding? Cloud seeding is basically a method by which we induce rainfall, or we forcefully create rainfall, force the atmosphere to make it rain in those conditions even when it is not supposed to rain. For example, this year as well, Saudi Arabia has actually done this cloud seeding and made it to forcefully rain when it was becoming too hot in the country. Okay, so how is cloud seeding done? Basically, an aircraft is sent to inject silver iodide or any other cloud seeding, let's say inducing uh, component or maybe chemical, and these chemicals are then dispersed throughout the atmosphere by that aircraft. Okay, what happens then is that these chemicals mimic the particles that serve as surfaces for condensation of water. So even if it is hot, there is always even if it is hot and in fact it is not raining, there is always humidity or moisture in the atmosphere, right? Water vapor always exists. The only difference is that clouds are not being formed and that water is not condensing and falling back on the surface of the earth, right? So to make that happen, to actually induce the formation of this silver iodide acts as a nucleus for the cloud to form, or basically for water to condense into droplets, right? So once that happens, water droplets start condensing on it, and slowly this starts becoming a drop, and then it becomes a larger drop, and then a larger drop, and finally the weight, the first of all there are a lot of drops which are creating this cloud, and then ultimately the weight of the droplet becomes big enough or large enough for it to not stay suspended in the atmosphere anymore, right? So in that case, what happens is that these drops start falling towards the surface of the earth, and once they start falling, they become rain. Okay, that is how rain is created, and this is basically of course man-made method which induces rain to occur even when it is not supposed to. So this is known as cloud seeding. Now, cloud seeding, the usual objective is to increase precipitation, rain or snow, be that either of them, depending on the temperature again, uh, to prevent, let's say, drier seasons from happening, to reduce the temperature. There can be multiple reasons for it. The most common chemical which is used is silver iodide. That is the same one which I had showcased to you in that image. But there are other chemicals or other compounds which can also be used for this cloud seeding process. For example, potassium iodide, dry ice or solid carbon dioxide, liquid propane, and all of these have the potential to be used as cloud seeding let's say chemicals, right? And then cloud seeding is of two types. The first is cold and the second is warm. Cold one uses chemicals like silver iodide, and warm uses salts like magnesium chloride. Okay, so these are the basic details about cloud seeding. Let's move ahead then. This is, I guess, the last slide in this chapter, wherein I'm going to discuss with you the factors affecting crop growth. Okay, so I think this has also been discussed in one of the other chapters, one of the previous chapters probably, but I'll discuss it once again with you. So this is a very crucial table, and this again I have cut it short to only 10 crops, but there are more crops close to 30 which are given in the notes, and you have to go through all of them. So this table, what it tells you is the optimum temperature both for germination and for the growth stage, the length of the day, the rainfall, and the altitude above sea level, which is ideal for these crops to grow. Again, these crops can grow in conditions which do not range in these, maybe slightly higher altitude or maybe lower rainfalls through, let's say, irrigation. All of those things can definitely occur, or maybe at even much lower temperatures by the use of, let's say, a greenhouse. A lot of man-made things can happen, but ideally the uh, conditions which this crop is getting for the growth should be in these ranges. So for example, even if you're using a greenhouse, the reason for using a greenhouse is because you ultimately have to uh, give the crop these temperature conditions. If you're using irrigation, that's because this is the ideal amount of rainfall which you need, but you're not being able to get this rainfall in your area. So then you have to induce let's say man-made methods like irrigation for the crop to get those ideal conditions to grow. Okay, so these are the ideal weather conditions for rice, maize, millet is again important, wheat is very very important. So rice, maize, wheat you should definitely know. Then millet, sorghum, barley, oats, a lot of crops are given. You should at least know the rough ranges for these crops. Maybe you can create let's say groups of your own, maybe wet crops, dry crops, or maybe hot areas, colder areas, whatever makes you remember them, but you should know this table for the exam. Okay guys, so that was the end of this chapter of agrometeorology. So thank you for watching this video, and if you have any other doubts, I hope it was a very simple chapter. I hope you did not have many doubts, and again, don't waste a lot of time on this chapter. Probably one or two let's say questions is the maximum that you can expect. Ideally, I don't see much coming in the exam from this chapter, so don't waste a lot of time. But if you have any other doubts, you can post it in the comment section below. That is the ideal method of doing it, because it saves a lot of time for you as well as us, especially for the students, because it's time is everything for you in the preparation of an exam. So if any other person has already asked a doubt which you were going to ask, it would save your time in asking the doubt, waiting for the answer to come, understanding the answer. You can just go through the comments, see the question, see the answer. You would already, most of those questions will already be answered. Still, if you have any other doubts, you can definitely put them in the comment section below. And if not in the comments, if you are still, let's say, shy enough wherein you don't want others to read your comments, then of course you can send them to us at our email id hi@litmode.in. And thank you so much for watching this video. Again, the ideal method of studying is first going through the notes and then watching these videos. It would save a lot of time. Don't begin with the video and then come to the notes. First notes, then video, and then the final revision or final note making, whichever you want to do. Okay, so I hope you will leverage your time. You will study fast. You will study only things that are important, because right now the exam is very near. So I hope every one of you does well in the exam, and for any other doubts, we're always there for you. Thank you. Have a nice day, and all the best.